Hi friends, when I started using Linux in the enterprise 20 years ago, there were still these old-fashioned guys, Unix guys, with beards, and they would tell me that Unix is so much better than Linux, and that all these programs that I'm using under Linux come from Unix, and these programs were all so hard to understand and so tedious. It was unbelievable. Yeah, but the worst program of all was called strace. When I first saw it, I said it looks as if it just vomits random characters into the console. I may demonstrate this. Here we have a Linux console, also known as terminal. In it, we have a command or application or utility called uptime, which shows you how long the computer has been up and running so far. In this case, it has been running 1 hour 28 minutes because I did some research for this video, which is, by the way, harder than clicking the like button. And now let's call strace uptime. Sorry, I wanted to say strace uptime because that is how you write it. And now the vomiting starts, and you see a lot of stuff that you don't understand. But they told me, well, it's quite easy. For every syscall that your program does, you see the name of the syscall, then some parameters, then the return code. For example, here, the syscall, it opens proc uptime, and it gets the file handle 3. Then it reads from this file handle 16 characters, and then it closes the file handle. Later on, it writes to the console exactly what it has read from this file handle, and then it closes the standard output stream. Okay, what is a syscall, I asked. So, turns out, a syscall is when your user-level program calls the kernel. So, in other words, it's like children calling their daddy, okay? Children can do whatever they want. They can have their box on the street where they sell lemonade. But once they need advertisement or a permit, they need to call daddy because only he has the credit card. But your programs can do whatever they want. But it's, for example, not allowed that your programs access the printer because when they print something and they have a parallel process running that also prints, then garbage will be the result. So they need the coordination of the kernel. Kernel will need to make sure that the first print job finishes and only then the second print stop can start. This is why syscalls are needed. Okay, I said, but what happens if my bug is not even related to a syscall and I produced an example program? This program here does nothing else than printing hello world. I compile it. I run it, and you see that it does exactly this, printing hello world. Okay, now I produce an endless loop right here, which is a bug, compile it again, and I run it again. And it does not even output anything, or the output is not invisible. The output is invisible because the program does not finish, so the buffers never get flushed to the console, so it will never be output. So, Control C to abort it. And now we run strace hello. We are not able to identify this issue, which is that it is continuing to assign 5 to an integer I. And we are not able to identify this issue because nothing happens on the syscall front. But then reality hit. When I first had to do a real troubleshooting in real world, I used strace and it just worked. I discovered an no end in the output of strace, and that means there's no such file or directory, and I found out that in this specific case I had forgotten to install a library which would contain this file, and once I installed the library, the program started running. So, troubleshooting successful. Over the years, strace and I have become real friends, and I appreciate what it can do for you, and I've grown a beard as well.